Good morning. We are going to be looking at Module 5, Lesson 9 today. There are a couple of things that we're going to do. First off, we're going to start off by reading our I can statement together, and I want you to read that with me where you are. And then just a few reminders. As we're going through this, if we come to a place where you need to stop and try something, I will try and remind you to stop your video, to just pause it, try the problem yourself, and then turn it back on. I want you to do that because I know how to do the work, as my class hears me say a number of times, but you need to try to do the work yourselves as well. So that's how we're going to move forward in this. So let's go ahead and start Lesson 9, and let's do the I can statement in 3, 2, 1. I can use the area model and division to show the equivalence of two fractions. So we've been using the area model all along, but now we were using division, multiplication with it last week. So now we're going to start using division to make equivalent fractions. So you'll see how that works, and I think hopefully it will go pretty quickly for you and you'll understand what you're doing. So let's move forward. This is our fluency, so we're going to practice this. And first off, this takes us back a little while, add and subtract. So we're going to write the numbers in standard form and then solve it. This is one of those times I want you to pause the video, solve it, and then come back and see if you get the same answer that I do. Alrighty, we are going to move forward. So it says 532,367 ones. So we need to think, well, how will I write that? Well, I've got 532,367 ones. And I'm going to add to that 423,142 ones. So here are my 423,000s and my 142 ones. And I'm going to go ahead and add those, starting with my ones. So I have 7 plus 2 ones. In tens, I have 6 plus 4 tens. Well, that's 10 tens, which means I'm going to put one of those over in the hundreds. So 1 plus 3 is 4 plus 1, 5. And I've got 2 plus 3 thousands is 5 thousands. 3 plus 2 10,000s is also 5 10,000s. And 5 plus 4 100,000s is 900,000s. So my answer is 955,509. And that should match you. Alrighty, let's go on. We're going to do the same thing, except this time we're going to subtract. And that's always just a little bit harder. So again, pause the video, do the problem, come back. All right, I'm going to start with 916,451s. And I'm going to subtract 615,137 ones. So I like to look at the whole problem and see if I'm going to have enough to do each area. And I don't have enough ones. I can see that right away. So I'm going to just go, I'm going to decompose those tens. I'm going to make it four tens, and then I'll have 10 ones. And then I've still got enough tens, got enough hundreds, have enough thousands, and 10,000s, and 100,000s. So that was the only one that I really had to do. So now I can come back and say, all right, 10 minus 7 is 3. 4 tens minus 3 tens is 110. 4 hundreds minus 100 is 3 hundreds. And I have 6 thousands minus 5 thousands is 1,000. 10,000 minus 10,000 is 0. And 900,000 minus 600,000 is 300,000. So my answer there is 301,313. All right, let's go on to the next one. This is going to be more familiar. This is what we were doing last week. So say the unit fraction, complete the number sentence to make an equivalent fraction. So our unit fraction that we started off with was right here, is 1/2. Now, since I know I'm going to multiply by something to get to a new fraction, I am going to go ahead and I'm going to write 1/2 right away to start. So 1/2 times. So now I've got to look at my problem here and I think, well, 1 times what equals 2? And hopefully that was really obvious to all of you. And that was 2. If I do it to the top, I've got to do it to the bottom. So 1 times 2 is 2, and on the bottom, or the denominator, 2 times 2 is 4. And that is my equivalent fraction that I've come up with. All right, here's another one. Again, pause the video, you look at it, you do it yourself. Okay, here we are. Once again, I am always going to write that fraction that I started with, which is 1/3. I'm going to write that first. Then I'm going to look and I see that I have to multiply 3 times something to equal the 6 down here in the bottom. So 3 times what equals 6? Well, I know that 3 times 2 equals 6. So if I do 2 on the bottom, got to do it on the top. So my new fraction, I've got 1/3 equal to 2/6. And that's my equivalent fraction. We're doing it again. Pause the video, do it on your own, and then come back. Okay, we're going to start with 1/4 is our unit fraction. And then I'm going to look. Well, it looks like it's in the numerator. So 1 times what equals 4? Well, I know that 1 times 4 equals 4. If I do it to the top, got to do it to the bottom. 4 times 4 gives me my denominator of 4/16. So 1/4 is equivalent to 4/16. Here we go again. You know the drill. Go ahead and pause. All right, we're going to start with the 1/5. And since it's in the denominator, we're going to say 5 times what is 15? Well, 5 times 3. If I do it on the bottom, got to do it on the top. And so 1 times 3 is 3. So 1/5 is equivalent to 3/15. All right, this time we have the directions changed just a little bit. We're going to say the fraction, and then we're going to draw a model to show 2/3 and draw the horizontal dotted line to find the equivalent fraction. So I am going to start here by writing our fraction. I'm going to go ahead and write 2/3. Even though I know we're going to draw this out, I still want to write my fraction, my number sentence. So I started with 2/3, which is what we started with over here. And I know that 3 times 2 is equal to 6, which is what I have in my denominator. Because I did it in the denominator, I have to do it in the numerator. 2 times 2 is 4. So according to this, I should have 2/3 equals 4/6. So now I'm going to draw my area model, and I'm going to see if that's actually true. So I'm starting off with 2/3. So I'm going to shade 2/3. And then I'm going to draw my dotted line. And now I have 1, 2, 3, 4, 5, 6 parts. Of those 6 parts, 4 are shaded, which does match my 4/6. So you can see the relationship between our area model and our number sentence. Okay, we're to our application problem, and I want you to look at this. So what fraction of a foot is 1 inch? What fraction of a foot is 3 inches? And they give you the little hint that 12 inches is equal to 1 foot. So you need to draw a tape diagram to model your work. So I'm going to draw a tape diagram, and I need to divide that into 12 parts because that's how many inches are in a foot. So I divide it in half, and then I divide it in half, and now I've got 4 parts, and now I can put my parts in. It's not perfectly even and beautiful. Sorry about that. But I have a total of 1 foot, right? So if I shade in 1, well, I have 1 part shaded of 12. So 1/12. So 1/12, what fraction of a foot is 1 inch? So 1 inch is 1/12 of a foot. Wow, that's super sloppy writing, but that's where we are. All right, now I'm going to do this again, and I'm going to draw, because this time I'm going to shade in 3 of my parts. So I actually want you to look at what I'm doing here. Okay, I've got my 12 parts, right? I'm going to shade in 3 of those. And I still have 1, so 3/12. 3 inches is 3/12 of a foot. Alrighty. That was pretty straightforward, I think. We'll get into where you can get that even find the fraction a little bit different, but we'll get there later. All right, we need to find an equivalent fraction for 3/4. This is reviewing. So if you remember, we can multiply this by anything that we want as long as we do the same thing to the top and to the bottom. So I'm going to start off with 3/4, and I'm going to multiply it by 2/2. That's pretty straightforward, right? So 6/8. But if I wanted to, I could say, you know what? I want to multiply it by 5/5. So I could do that. And 15/20 is still equivalent to 3/4. Those are equivalent and the same as 6/8. So if 3/4 is equivalent to 6/8 and 3/4 is equivalent to 15/20, then 3/4 would be equivalent to 6/8, right? All right, we're going to look at this one. True or false, 2/3 is equal to 4/12. So the way we're going to do this is we're going to set it up how we've set up all those other problems, right? And again, you should do this on your own and then come back. And we'll see if it's true. So we're going to put our multiplication signs in. We're going to put our 2/3 in. And we can do either the numerator or the denominator. So let's just do the numerator. We're going to look at the numerator and say, well, 2 times what is 4? Well, 2 times 2 is 4, correct? So if I do it to the top, I have to do it to the bottom. 3 times 2 is not equal to 12. So we would say, is this true or false? It is false, because both numbers need to work. Our numerator and our denominator need to work to make this something that we can live with. Alrighty, this last problem, I want you to pause the video and do 5,392 divided by 7. I'm going to do the algorithm on this, and if you need to figure it out a different way, that is fine as well, but come back and check your answer. So here we go. We are going to divide. Hope I have room on this little space here. 5,392 divided by 7. Well, I'm looking at it. I can see right away that 7 does not go into 5. So I'm just going to put an X above that because there are no 7s in 5. So I'm going to have to go over here to 53. Well, 7 into 53, I know that 7 times 7 is 49. So I know that 7 is up there. And then I'm going to say 7 times 7, well, that's 49. I'm going to subtract that and get rid of that because we're getting rid of it. And 13 minus 9 is 4. And then I need to bring down my next number, 49. Ooh, that works out really handily, doesn't it? 7 into 49, we know is 7. So we can do 7 again, and 7 times 7 is 49. Now that's 0, but I've got to bring down that 2 that's left in the 1's place. Well, we know that 7 doesn't go into 2. That does not mean that this 2 is a remainder. I have got to put something above that 2. I've got to have a placeholder. So I need to put my 0 up there. 0 times 7 is 0. And then I know that 2 minus 0 is 2. So that is my remainder. Again, the big thing about this one is making sure that even though you might have in your head, oh, I'm just going to use that 2 as a remainder, make sure that you show that placeholder above it and that you have a 0 up there. Alrighty. All right, let's look at this fraction that we've got right here. What fraction is that? If you have a piece of paper there, which you should because you should be writing all of these down on something, I want you to write down that fraction. As I look at it, I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 altogether, so that's my denominator. And of those 12, 1, 2, 3, 4, 5, 6 were shaded. So I have 6/12. So can you see any equivalent fractions? So what we're going to do is we're going to use division to prove which is which. So if I were to take this and instead of having it divided into 12ths, I divided it into 2 instead, how much of that is shaded? If I do it into 2 equal parts, well, I've got 1 of the 2 shaded. If I'm going to do division to prove it, division works the same way as our multiplication. Multiplication, if you do it to the top, you have to do it to the bottom. Division, same thing. You do it to the top, you do it to the bottom. So we're going to start out with 6/12. I want to get to 1/2. And so I'm going to divide. And I start with my fraction that we started with, 6/12. And I know that 12 divided by something is going to equal 2. Well, I can do this backwards if I want. I know that 2 times 6 is 12, so 12 divided by 6 is equal to 2. If I do it to the bottom, I have to do it to the top. And 6 divided by 6 is 1. So that right there, I proved it using division. We're going to do more of these, so if that didn't click, don't worry, keep practicing. Okay, so we're going to represent, I want you to follow along with this on your own piece of paper. So we're going to draw a model and we want to represent 2/8. So I start by dividing it in half, then into fourths, and then I know that each one of those fourths needs to go into 2. All right, I'm going to show 2/8. Okay. So now I'm going to say, oh, you know what? I'm going to group 2 units and I'm going to do this in a different color so that you can see it to make 1 unit. So instead, I'm going to do those 2 become 1. There's those 2. So now I'm grouping the 2 units. So now if you look at it, well, how many units do I have? So I started with 2/8, right? But now I have 4 units, and one of those is shaded in. So 2/8 is equal to 1/4, equivalent to 1/4, right? Because I shaded in one group of 2, and there are 4 groups of 2 altogether. So if I were going to write a division problem to show that, I would start off with my 2/8, and remember that I want to get to 1/4 on the end. So we start off same way that we start off all of them, and we're going to start with 2/8 because that is our fraction that we started with. And I know that 8 divided by 2 is equal to 4. And so if I did it to the bottom, I have to do it to the top. So 2 divided by 2 is equal to 1. So that tells me that 2/8, that confirms what I've got here, that what I drew with my area model. 2/8 is equivalent to 1/4. Alrighty, we're going to go back and we're going to draw a model to represent 3/12. All right, let's do that again. So here we go. Oh, those 12s, you know, those kill me because they don't look very even by the time I'm finished. I keep thinking I'll be better at it. I'm trying to be more careful. Okay, I have 12 parts now. And I'm going to shade in 3 of those. So I've got my 3/12. Now I'm looking at this and I'm thinking, okay, if I can do, maybe I can shade some more groups turn it into groups of 3 like we did last time. And then I'll be able to get a new fraction. So I'm going to just group groups of 3. So here's one group of 3, 2 groups of 3, 3 groups of 3, and 4 groups of 3. So my equivalent fraction is going to be, has a denominator, it's divided into 4 parts now. I've got 4 units, so I am going to put a 4 on the bottom. All right, so how many groups of 3 are shaded? Well, just 1. And how many groups of 3 are in the whole? Well, 1, 2, 3, 4. There are 4. So I should have a fraction of 1/4. So I'm going to set it up again, same way I did before. I'm going to start with my original fraction, which is my 3/12. I'm going to divide by something to get my new fraction. So if I'm looking at this, 3 divided by what is equal to 1? Well, I know 3 divided by 3 because 1 times 3 is 3. And then if I do it to the top, I got to do it to the bottom. And 4 times 3 is 12, or 12 divided by 3 is 4. So my new equivalent fraction is 1/4. Again, we're just going to keep practicing these. Don't worry if you're not at all right away. Okay, we're going to draw models to represent 2/6 and 4/12. All right, let's see if we can do this. And we're going to see if we can make them the same. So it's the same unit fraction. So we're going to go 2/6. And that's going to be right there. And we're going to do 2/6. Wow, so sloppy. And then we're going to do 4/12. So even though my drawings are not going to be true in terms of size, they are obviously, well, they're kind of close. We'll see. Anyway, we've got 4/12. 1, 2, 3, 4. Okay. So we're going to rename them and see if we can turn them into the same, each of them into the same fraction. So we're going to follow that pattern that we did before. I'm going to go ahead and re-block these in groups of 2 for this one. And now if we look at that, I've got, instead of 6 groups, I've got 1, 2, 3. So 3 is my denominator. And one of those is shaded in. So that's 1/3. Let's go over to this next one, and we've got it in groups of 4 this time, right? 4 of them are shaded, 1, 2, 3, 4. So you're going to count 1, 2, 3, 4, and 1, 2, 3, 4. Once again, I have a total of 1, 2, 3 units, and one of those units is shaded. So those two are equivalent. So now we're going to write division problems to show that. So we're going to start here. Hopefully you can see this well. We're going to start with our 2/6. We're going to end again with 1/3 over here. And we are going to start 2/6 here. We're going to divide. And 6 divided by what is to 3? Well, 6 divided by 2 is 3 because 2 times 3 is 6. So same on the top and the bottom, 2 divided by 2 is 1. Over here, we're going to start with 4/12 with our next fraction. But again, even though we started with 4/12, it still ended up being equivalent to 1/3. So even though these are 2 very different fractions, they are equivalent to the same one. So we start with our problem right here. We write 4/12 divided by. Well, 4 divided by what equals 1? Well, I know that 1 times 4 is 4, so 4 divided by 4 is 1. If I do it to the top, I've got to do it to the bottom. 12 divided by 4 is 3. And that's how we get to both of those fractions there. Alrighty, here we are. We are ready to try and do them on the word problems. What I'm going to do here is I will work through one of the problems with you, and then I am going to leave it to you to do the rest. So each section I will do one of the problems. The first problem, 1A, is already done for you. And so these are the pieces that we expect you to have. I'll look at B and do B with you, and we will do the same thing. So we want to get into larger units. So we have a page. Right now we have 6 units altogether. 1, 2, 3, 4, 5, 6. 3 of those are shaded. So I'm going to start off. My fraction that I start with is 3/6. And I know that I've got to express that in a number sentence, so I've got to turn it into something else. And I can tell if I just make each of those units 3 units, that now I can divide it, and I have 2 units. So of those 2 units, one of them is shaded. So I'm going to start with 3/6. I'm going to do some division. to equal 1/2. 6 divided by 3 is 2. If I do it to the bottom, I need to do it to the top. So you're going to do the same thing with C and D. That is a very similar sort of problem. Now we have, oh, whoops, I got to go back to them right there. And then we get to number 2, and we're going to do the same thing with these. They just look a little bit different. So I'll do A with you, and you can go ahead and do that first and come back and check and see if you did it correctly. So, but we'll just start that one together. As I'm looking at this, I can see I've got 1, 2, 3, 4, 5, 6 units all together. That is my denominator. And I can look at the top, 1, 2, and I have 2, 6. Now, I am going to make that larger. So because I've got 2 shaded, I'm going to put it into groups of 2. There's 1 group of 2, 2 groups of 2, 3 groups of 2. So now I have 3 groups total, and I will put that as the denominator of my new fraction, and I have 1 of those groups shaded. So I will put that as the numerator. Once again, I put 2 6. I'm going to divide right here. And I can see that 6 divided by 2 is 3 because I know that 3 times 2 equals 6. So if I do it to the bottom, I do it to the top. So that fraction becomes 1/3. So you're going to do that same thing with each of these. I'm going to go ahead and do D as well. I want you to do this on your own. So right now, if you're listening, I want you to pause, do these on your own, and then you can come back. All right, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 altogether, which means that's my denominator. When I look at shaded, I have 2 of those are shaded. Okay, so I've got 2 12s. Now I'm going to compose those into larger fractions. I'm composing because I'm making them bigger, decompose if I'm making them smaller. So because I have 2 shaded, I'm going to turn everything into 2 shaded. So I went from 12 groups or units to 1, 2, 3, 4, 5, 6. So at the end, I've got 6 units. Of those 6 units, 1 is shaded. So I went to 1 6. So now I'm going to set up my problem, my division problem. I'm going to start with the fraction I started with, which was 2 12ths right here. I'm going to divide to find what I need to find to get to 1 6. Well, actually, how many units did I start with in the original? I started with 2. So if I divide it in 2, 12 divided by 2 is 6. Do the same thing to the top. 2 divided by 2 is 1. Look at the size of them. So they started off, I can look, our total number of units, which is the numerator. All right, so I want you to think about this. I want you to write down the answer to this before we talk about it. But what happened to the size of the fractional units when you composed the fraction? So remember when we first started, I want you to picture that. And if you need to go back and look at that, what smaller and they got bigger. So the units got bigger, right? And what happened to the total number of units in the whole when you compose the fraction? Well, again, it got smaller. So total number of units got smaller. All right. For this right here, they're asking you to show 2 6 in our first area model. So I'm going to do it a little bit different. I'm going to do it a little bit how we did last time. Oh, so not even. You know what? I have to erase that because that really bugs me. Not even at all. Let's try that again. I'll try and make my thirds a little bit more even. So I'm going to show 2 6. So if you look, I've got 1 2 3 4 5 6 all together. So I've got 2 6 to start. I'm going to shade in 2 of those. Does that make sense? All right, in the second area model, I'm going to do the same thing. I'm going to show, except I'm going to show 3/9. So I'm going to draw my thirds, draw my thirds. It's not perfect, but we'll pretend. And I'm going to shade in 3/9. Now, both of these can be renamed as the same fraction. So I'm going to go back to where I need to take my fraction. I need to put them into larger units. So because I have 2 of these here, I'm going to count 1, 2, and put them in these groups of 2 units. All right. But now I have a total of 1, 2, 3 units and 1 shaded. So we know what that means. I say 2, 6 divided by, 2 divided by 2 is 1, and 6 divided by 2 is 3. So I'm showing that 2, 6 is equivalent to 1/3. Let's see if that works for the next one. I'm going to say I've got 1, 2, 3 together units, so I'm going to put those 3 into 1. And 1, 2, 3 into another one, and 1, 2, 3 into another one. So now again, I have a total of 3 units, starting with 3/9. So I need to divide by 1, 2, 3. I'm going to divide by 3. 9 divided by 3 is 3, and 3 divided by 3 is 1. So you can see that we ended up with the same thing. And actually, that part would be the answer to this second part. All right. One more time, and you're going to do this one on your own, but it's the same thing. In the first area model, you'll show 2/8. In the second area model, 3/12. You're going to show how both of those can be composed or renamed, and then you'll give a number sentence down there. All right. And that is the end of this lesson. Once you complete this part, you can go to your Google Classroom, go back and do the exit slip that is associated with this. Have a good day.